Hey there, students. Welcome to part 3 of the Algebra and Functions and CAHSEE review. In this installment, we're going to be going over questions 91 through 100. All right, let's take a look at question number 91. 91 says, which best represents the part of the graph shown below? So this is not a complete graph, it's just a portion of a graph, basically the portion of the graph that falls in the first quadrant. Now, if we examine these options that we have first degree equations. A and C are first degree, and B and D are second degree equations, okay? So first degree basically because the power is 1. If the power is 1, you don't actually have to put any power there, okay? So what kind of graphs are represented by first degree equations? When you have a first degree equation, those are represented by lines, okay? So if you have an equation of the form y is equal to a to the x, that's going to be a line going up. And then if it's y equals negative a to the x of that form, you have a straight line going down, okay? The b, the y-intercept is 0 in both cases, so they basically go through the origin. All right, but what if you have y equals a to the x squared? Notice this is a first degree equation. You have a straight line. They're linear relationships, right? But if you have an x squared, it becomes a parabola. Okay, so the graph becomes a parabola opening up, something like this. This is just a sketch. And then if you have y equals negative 8 to the x squared, you're going to have a parabola that's opening downwards. Okay, like an upside down U. Let me sketch that again. So you have a parabola opening downwards. Okay, all right, so let's take a look at this graph right here. It's not a linear graph. It looks basically like a parabola, right? So we can clearly see that it cannot be option A or option C, because for option A you have a straight line going up, and option C you have a straight line going down because of the negative slope. So is it B or D? Now, since this is a parabola opening upwards, that means A has to be positive as indicated here. Okay, so we can clearly see that the correct answer is option B. This is part of a parabola where A is positive, an upward opening parabola. If it were D, it would have been opening downwards, but that's not the case here. So our answer is clearly option letter B. All right, let's take a look at number 92. It says, what is the slope of the line shown in the graph above? Now, if you're given a graph and a line, what you want to do is you want to pick 2 points that fall on the line and also fall on the intersection of the vertical and horizontal grids on your coordinate system. Okay? So, one point I like to pick that meets that description is this point right here. You see this point falls on the line, and it also falls on the horizontal and vertical grids. Okay? Next point. Can we pick this point? Is that a good point to pick? Let me put it on red. Is this a good point to pick? Well, it falls on a line and a vertical grid, but it doesn't fall on a horizontal grid, so that's not a good point to pick. How about the next point? Following the line, this point right here. This is an excellent point to pick because it falls on the line of vertical and horizontal grid, so it's easy to calculate to determine the slope, okay? So what on earth is a slope from a graphical perspective? The slope is a rise. If you're going up, it's going to be positive. If you're going down, it's going to be negative. Okay, so rise carries a sign. And over the run is always the vertical horizontal displacement. You always run to the right. Okay, so if you look at this point, you notice we have a rise going up. How many units is that? We have to be careful. It looks like every tick mark is 1, so this is negative 1. So we have a rise of 1 unit. So you rise 1, you rise 1, rise 1, and then you run 1, 2. Okay? So in this graph, the rise equals positive 1. Remember, the rise could be positive or negative, and the run is 2. So if the rise is 1 and the run is 2, the slope is going to be 1 over 2. Okay? So our answer for number 92 is clearly C. All right, let's take a look at option 93. It says the slope of a line shown below is 2 over 3. So in the reduced form is 2 over 3. What is the value of D? So we know slope is rise over run. So based on this information, slope is rise over run. Based on this information, right here, we know the slope is 2 over 3, or any multiple of this. So basically, any multiple of the rise and the run. So in this triangle right here, this is your rise, positive rise, and this is your run. So using this formula, since the slope of this line is 2 over 3, the rise and the run of this line, regardless of whatever value it is, must be um, proportional to 2 over 3. So you're going to have this is equal to the rise, which is d over 6. Okay? Now we can solve this intuitively or using algebraic methods. Let's solve it intuitively first. What happened with the run? If you look at the run, you notice that the run was doubled. So what do you think you're going to do with the rise to preserve the proportionality that's happening here? Since you double the run, you also have to double the rise in order to keep the slope consistent. So if you double 2, what do you get? You clearly see that you get 4, so the answer is 4. Okay, so thinking of it intuitively, the fraction you can reduce to get 2/3 is basically 4 over 6, multiplying the top and bottom by 2. Okay? All right, how about we want to solve this using algebra if it's not intuitive to us? Well, we have to set up the ratio 2/3 rise over run, as indicated up here, is equal to the rise over run as presented to us on the line, d over 6. Now we want to isolate d. To isolate d, what you do is multiply both sides by 6 over 1. Okay, that basically isolates d. So you see this 6 divides with that 6 right there. So you have d is equal to 12 divided by 3. And what is 12 divided by 3? Is 4. So that's another way you can actually arrive at the value of d. Okay, and then when you do 4 over 6 and you reduce it, your answer is going to be 2/3. So you can see that our answer is option letter B. All right, let's take a look at question 94. It says, what is the equation of the graph below? Now, if you look at the options that we have, they are all presented in y equals mx plus b form. Y equals mx plus b form. Now, what is this called? This is called the slope-intercept form because it makes explicit the slope and the y-intercept. All right, so let's use the slope and the y-intercept of this line to determine the equation that matches one of these equations right here. All right, so b is the y-intercept. Is basically like your beginning on the y-axis. All right, so what is the b, or your beginning on the y-axis? Where does this graph intersect the y-axis? We see it intersects here at value of 3, so you can clearly see that b equals 3. All right, m is known as your rise over run. Okay, so you pick 2 points and you compute the rise over the run, and that will be your m, or your slope. Okay, so using this point, this is a good point because it falls on the intersection of the line, vertical and horizontal grids. Now let's pick the next point that falls on the intersection of the line, the vertical and horizontal grids. This line meets that expectation. So we have a rise of 1 and to this point and a run of 1. So what does that make our slope? Our slope is rise over run, 1 over 1. So m is equal to 1. So how do we generate the equation of our line? Well, we're going to plug in m and the m and b values into the equation y equals mx plus b. Okay? So we know that m is 1, so this will plug right here. And then b is 3, that will be plugged right here. Okay? So the equation of this line is going to be y equals 1x plus 3. Now, since 1 is a multiplicative identity, 1 times x will yield x. So we can reduce this into y equals x plus 3. We can clearly see that our answer for question 94 is option C. All right, let's move on to question 95. It says, what is the slope of the line below? Now let's remember the slope formula. The slope formula is y equals y2 minus y1, which is a run, over x2 minus x1, which is a run. This is a rise, I'm sorry. This is a rise along the y, and this is a run. Okay, so in this point, this is x1, y1, and this is x2, y2. Okay, So we can use this formula to find the slope here. Let's write that correctly. So m, or your slope is, that's a slope formula. Okay? All right, let's use it here. So the slope using that formula is going to be y2, which is 5, minus y1, which is 3, over x2, which is 5, minus x1, which is 2. So if you do the calculation, 5 minus 3 is 2, 5 minus 2 is 3. So your slope is 2 over 3. So our answer is C. Now the question is, did we have to do all this calculation to determine the slope? And the answer is absolutely not. You notice that in this triangle, we were provided with the rise. You see, you're provided with a rise, and also you're provided with the run. And that is all you need to determine the slope. Okay, if you're not provided with a rise and a run, then it's beneficial to use this formula. But if the rise and the run are explicitly stated, then your slope is simply the quotient of the rise over the run. Okay, so the rise is 2 and the run is 3. So with these two values, that's more than enough information to find the slope. You didn't have to do this formula, okay? But the formula works too. So these are two different methods of finding the slope, giving two coordinates and the rise and the run. But we can see that this method, option 2, let's call this option 2, is much quicker than method 1 because method 1 requires more work. All right? So there you have it. All right, let's take a look at 96. It says Mario drives 1,500 miles every month. Which line plot correctly represents Mario's total miles driven over a period of 6 months? So if you drive 1,500 miles a month, how about in 6 months? Well, 1,500 miles in 1 month, then in 6 months, you have to multiply this by 6. So you have 6 times 1,500 for 6 months. Okay? All right, so what is 6 times 1,500? Let's do the calculation right here real quick. 6 times 1,500. 6 times 0 is 0. 6 times 0 is 0. 6 times 5 is 30. 0 carry 3. 6 times 1. 6 times 1 is 6 plus 3. Right, it's 3. Well, that's 9. So 9,000 miles. So what we're going to do is we're going to inspect all these, the 4 options we have, and we'll see the graph that traces 6 months to 9,000. Basically, I'm looking for this ordered pair 6 to 9,000, and that will be my correct graph. Okay, so let's take a look at option number A, option letter A, sorry. So if you start from 6 to the line, and the line to the y, what is the output? 9,000. So that's exactly what we want. We can see that the answer is A. If you take a look at option B, for example, option B, if you trace from the 6 to the line, and what is your output? Your output is 1,500. That's no good. If you look at option D, 6 is not even anywhere close. 9,000 goes to 1. So you can see that in 1 month, it covers 9,000 miles. But the question told us that in 1 month, it covered 1,500. So you can see that this is not a valid result also. So B and D are clearly wrong. And if you look at option C, how many miles were covered in 6 months? So if you trace from 6 to the line, what do you notice that the output is? It's just like option B. The output here is 1,500 miles. Okay, so let's graph it. So if you go from 6 to the line, and then from the line to your output, you notice that your output is 1,500 miles. So this one is not wrong. We're looking for an output of 9,000, and we see that only option A meets that expectation. All right, so that's the answer. All right, let's take a look at number 97. It says the graph below shows Francine's electric bill for 4 different months. What is the price per kilowatt hour of Francine's electricity? So we're basically asked to find the slope here. So since it forms a linear pattern, what we want to do is we want to look for 2 nice points to calculate our slope, or our rise over run. Okay, so let's go ahead and create a trace pattern. So for 200, draw a straight line to September. You see the output is 30. which is nice. For October, it looks like it's 300. Let's see if we can draw a straight line there. Boom. 245. Well, that's not bad, but let's see if we can get get a multiple of 10 for easier computation. For 40, for 400, it takes us out to 60. Wow, that's beautiful. That's good. So we already use that. So what I'm going to use is I'm going to use this point. Let me put them in green. This point. The coordinates of this point is 200, comma 30. I'm going to use this point, and I'm going to use this point right here. Coordinates are 400, comma 60. Now, if you chose to use this point right here, 300, comma 50, you'll get the same answer, but it just involves more steps. Okay, I like to use multiples of 10 because it's easier. Okay, now what I'm going to do is I'm going to calculate the rise over the run. Okay, so this is the rise. Let's use a different color to make it obvious. I'm going to use, let's use a blue line. I'm going to use a blue line that is dotted. All right, so let's do that again. All right, so let's draw the rise. That's the rise. Okay, and that's the run. And there goes your right triangle. Okay, so the rise of the run will tell us what the slope is. So question is, what's the rise? Okay, what is the rise? If you go from 30 to 60, what's your rise? You have a rise of y2 minus y1, which is $30. So this rise is basically how much did you increase? So it's $30 for that. That's your rise. What's your run? If you go from 200 all the way to 400, by how much did you increase? That's x2 minus x1. So 400 minus 200, the run is basically 200. Okay? So this is your run, and this is your rise. So the question is, what is the slope with this information? The slope is going to be rise over run. Okay, we noticed we had a rise of 30 and a run of 200. Now, how can we express that in a decimal form consistent with the options we have? We can start out by dividing by 10. 10 goes in cancels that out, so we have 3 over 10. So the slope is 3 over 20. Now, let's express this in decimal form. To do that, we're just going to use long division. So for this one, we have, okay, yeah, a quick correction from, all right, our results are fine. So let's go ahead and divide it out. So let's do it. So we're going to have 3 divided by 20. So the top dog goes in the doghouse. So the numerator goes into under the division sign, and the 20 goes outside. So 20 goes into 3 how many times? 20 doesn't go into 3, so you need to put a 0 point and add a 0 here. We're going to go to the decimal world. So 20 goes into 30 how many times? It goes in once. 1 times 20 is 20. You subtract, you have 10. And then we can add a 0. 20 goes into 100 5 times. 5 times 20 is 100. So our answer, the slope is going to be 15 cents. Okay, so the price per kilowatt hour is basically the slope, and our result, price per kilowatt hour, is 15 cents. All right, so there you have it. All right, let's take a look at question 98. It says a grocery store sells 2 cans of soup for $1.50. His relationship is graphed with the number of cans on the x-axis and the cost on the y-axis. What is the slope of the graph in dollars per can? So basically what we have been provided with is the rise and the run, and also how to determine what they are. Okay? Now remember that your run So let's first of all make ourselves a nice little triangle. So let's say we have a line like this, and then we have, that's our run and our rise. Okay? So you have to remember that you run along the x-axis. Okay? So this is the direction of your run. And your rise, being positive or negative, it goes along the y-axis. If it's positive, it goes up. If it's negative, it goes down. So you're told that cans is on the x-axis. So this 2 cans is your run. So 2 is your run. All right? And then the cost is graphed on the y-axis. So this is a number of cans, and this is your cost in dollars. So that's graphed on the x-axis. So it's telling you that this $1.50, 1.5 is your rise. Okay, because you rise along the x. So if this is your run, 2 is your run, and 1.5 is your rise, what is your slope? Remember what the formula for slope is, right? Slope is rise over run. Rise over run. So what we're going to do here is we're going to compute the value of the rise, which is 1.5 over the run, which is 2. So since this is to the 10th decimal place, we're going to make that the same in the denominator. So all we'll just do is put 0.0. Okay? Now let's convert these two. We can move the decimal point of the top and the bottom one place by multiplying the top and the bottom by 10. If we do that, the decimal point moves to the right ones on the top and the bottom if we multiply by 10. Okay? So as long as the shifts in the decimal point are identical on the top and the bottom, it cancels each other out. So 1.5 over 2.0 is the same thing as 15 over 20. Now, can we reduce 15 over 20? Absolutely. Any number ending in 5 or 0 is divisible by 5. So we can reduce by 5, divide this by 5, divide that by 5. That yields 3 over 4, 3 quarters. How much is 3 quarters? If you have 3 quarters, how much is that? It's 25 cents times 3. So 25 cents times 3 is 75 cents. So 3 quarters is equal to 0.75. Okay? So that's what 3/4 is in decimal form. So our answer for 98 is clearly option letter B. All right, and if you want to change 3/4 to 0.75, you can always use long division to figure it out, but you'll end up with 0.75. Okay. All right, let's take a look at question 99. It says in the inequality 2x plus 10,000 is greater than or equal to 70,000. X represents the salary of an employee in a school district. Which phrase most accurately describes the employee's salary? So the employee's salary is X. So what this problem is assessing is our ability to solve linear inequalities and interpret what the answer means. Okay? So how do we solve this equation? 2x plus 10,000 is greater than or equal to 70,000. How do we solve this? We can do this in a two-step procedure. First of all, we subtract 10,000 from both sides and then divide by 2. That will tell us what x represents. Okay? All right, let's go ahead and do it. Subtract 10,000 from both sides. Subtract 10,000. Remember, it's only when you divide by negative, that's when the inequality changes, all right? We're not doing that here, so the inequality doesn't change. So you have 2x is greater than or equal to 10,000 minus 70,000 minus 10,000 is 60,000. All right, now to isolate x, we divide both sides by 2. So x is greater than or equal to $30,000. So if x is 30,000 or greater, that means that the salary cannot fall below 30,000. Okay? So this is the least amount that you could possibly have. So which of these represents that? So more than, if you look at more than is basically tells us that x is strictly greater. Less than means x is less than. At most means x is less than or equal to. At least means x is greater than or equal to the amount. Okay, so this we're doing with 30K here. $30,000 is what we're looking at. Okay, So which one is correct? We can see that this is the least amount, 30,000 is the least amount that it can be. So we can see that option A is the best representation, or is the only representation for this option here, okay? So if you think about a number line, for example, greater than or equal to, if you draw the number line, um, that is the least amount. 30,000 is the smallest. 30K is the smallest. Everything else is greater. Okay? So this represents at least. Everything else is talking about something else. All right? So you can see that this is close, but more than would be an open circle, but it could be 30,000, so this one doesn't work. So our answer is clearly option A. Okay, let's take a look at number 100. It's assessing our ability to solve um, uh, equations, algebraic equations with variables on one side. So to do this, this is a two-step equation, two-step procedure. We're going to get rid of the 3 and then the 2. All right, so to do that, you add 3 to both sides. And then you have 2x equals 10. And then to undo this multiplication, 2 times 10, you use the inverse of that, which is division. So divide both sides by 2. And then that yields x equals 5. So we can clearly see that our answer is option letter D. Okay, so there you have it. So thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel for next parts to this review series and other cool math clips. You can comment to let me know what you think, or click like if you liked it. Feel free to share this video with your friends via your social networking program, Facebook, Twitter, Google+, or Pinterest. More videos can be found on mygosub.com. Thanks again for watching and have a wonderful day.